Today's module we will be discussing about the application of satellite data in weather studies. The earlier three sessions or modules we discuss about the basic concepts of remote sensing, and then we introduce what is satellite meteorology in brief, and then we just noticed how the satellite meteorology evolved over a period of time. Over 50 years of time, we have come a long way. That is way back from 1959 to 2009. From 2009 to 2019, still a quantum jump has been taken place into evolving of satellites, sensors, bands, etc. Then we discuss about all disruption yesterday and today about the satellite data-based products and then image interpretation. And today's talk we will be covering about how the data will be applicable for weather applications and new techniques like based on the day microphysics and night microphysics, how in the operational setup we are using, though we discussed little bit in the previous model itself. So with this small introduction, I will take you to another 50 slides or so. Probably let me try to do some justice on it, and then the PPT in PDF form is available. Whatever interesting, probably you can download and then can see yourself there in a given somewhat descriptive way also. So that should not be any problem in understanding as such. This is a mobile-based connection. Probably each slide will be advanced somewhat in delayed mode through hotspots. So now this is the expert WMO Secretary General way back in 2003 and 2004 based on the themes of disaster management. So we know pretty well the natural disasters, about 80% are of meteorological or hydrological origin, a cyclonic storm or flood or drought, something like that. Both are placing on hydrological origin, flood and drought. And then about the meteorological origin, thunderstorm, severe local storms, cyclonic storms, and then heavy rain and showers without any cyclone or something like that. That is also another issue which causes even flash floods and other thing. So way back in 2000, US-based company, insurance company, they estimated somewhere at the order of 960 billion over a period of 50 years as a compensation to the participants, the claimants, etc. that was given, which were purely of the natural disaster, purely of meteorology or hydrology based. So this post does probably how the remote sensing will help us to save the life and property, and then with that only the satellite technology we are discussing about, and then it has given really a big relief somewhere. Even now also we have to do a lot because there are some underdeveloped countries, and then there also probably this set of information has to go. Now the current day technology we are able to coordinate and cooperate, and then thereby the entire human being throughout the world will be in a position to have comfortable living on it. So the disaster management part of it, as well as the natural public weather service point of view, probably we are having the disaster weathers like the tropical cyclone, severe local storm, which has hailstorms and the thing, and thunderstorm, then rainfall associated with this, and droughts, and then in addition vegetation monitoring. So about the last point, let me do some what you call, if time permit, I'll throw some light on vegetation index as such. So now probably how the satellite has come in, and then how we are using in data application. That is the one probably prior to 1960 is the pre-satellite era, and after 60 is the satellite era, because you remember 59 was the first meteorological satellite launched on board without only we are experiencing. We have just done in a position to get the vertical file of atmosphere, and then all the meteorological parameters for the day-to-day forecast, etc. We started retrieving from 1960. That is 1960 data. Prior that is the satellite era, and then later on 1960 is the post-cyclone era. So you can just see that over the eastern North Pacific, the number of traffic earlier it was based on the long-term record only 10 per annum. So after the satellite, it has started up to 16.5 per annum. For Australian region, it was hardly 4 per annum pre-satellite era. Now it has gone beyond 10 per annum after the satellite era. In the Indian scenario, the very severe cyclonic storm with the core of hurricane wind, that is the usual terminology we used to say. So the current day satellite era was showing almost 2.5 times more than that, whatever be the long period average of 100 years earlier, wherever we are having the record. So what is the difference? The why this is needed? Because the earlier one was based on some sort of what we call uncertainty there. Unless a ship is reporting something, probably we are not in a because the ground-based radar will be hardly having surveillance up to 400 kilometers. Beyond that, normally the pulse will not go. In the worst case, a best MDDS, minimum digitally detectable and discernible signal from the radar point of view. So with the high value of this one, we can go up to 500 kilometers. Beyond that, we cannot go. So any cycle is happening beyond 500 kilometers, it was going unnoticed earlier. So whereas in the case of satellite era, they are all completely detected. That is the difference. That is what, how the satellite era has helped us to get the statistics to build up the climatology on severe weather phenomena. The first picture on the left hand side and the middle picture, they are of the same time. 10 UTC visible picture, 10 UTC IR picture. You can very well compare and contrast between the cyclonic signatures that we already discussed with. And then the next one is 2003, some other time date. That is, the earlier one was 11th May. This is on 12th May, which is from the Dundee receiving station, GOES satellite, Meteosat satellite they were receiving at the time, and then that was coming in. So you can very well just compare and see that, how the left hand side picture and the middle picture, we are unable to get the pinpointing of the center of the eye. There are some cases in which this set of what you call center cannot be pinpointed through satellite. Reason being, probably clouds get obliterated due to what you call maybe if it is not fully organized, and strong vertical wind shear is playing a role. So some of the clouds will be drifted, and then over probably the clouds will be just masking over, and then they are unable to hit the center. So this is a practical problem as a forecaster we are facing, and maybe some other storms they behave like that. So this particular image, we used to say that a shear pattern, say, and or CDO dense overcast pattern, dense overcast pattern cyclonic storm, where the eye is not clearly seen. So this is all quite natural, because the way in which we understand nature does not understand physics. That is why this sort of thing is coming in. So for identifying and fixing the center, way back in 1960s and 70s, the Dirac technique was coined, and how it was evolved, probably that has been listed for operational forecaster. For our understanding, I am just showing you. So depending on the climatology based on the satellite retrieval so far with the images, etc., Dirac has developed the technique with the intensity numbers are coined as T numbers. So the optical intensity is why T is coming in, and the T numbers right from T1 to T6 has been given over here. Any number beyond 2.5 is a cyclonic fury. So this is the first thing we are supposed to know. The Dirac technique first identify the central dense overcast coefficient, and then the whirling feature, waving feature, and etc. Probably over that we have to match as a pattern recognition. Then we will be in a position to estimate the center. So the centers, etc. Depending on the pattern, we will be increasing the T number. It goes up to T6.5 over this particular place, wherein the super cyclone, in other language, in some other part of the world, the hurricane, very severe hurricane, etc. So this is the way in which normally a pattern recognition, with that the intensity is estimated. Depending on the intensity, probably we used to call, because cyclone is evolving. There was a query on the first day itself. Cyclone is a low pressure thermodynamic heat engine. Somebody was saying, I also admitted that way. So it starts from its family as a low pressure. Whatever I am giving as what you call acronym, so that has been given in the center portion for expansion. So underlined portion alone, L stands for low, DD stands for difference, C stands for cyclones on that portion I highlighted. So it depending on the intensity number, the wind speed, the sustaining wind speed that has been tabulated for a super cyclonic storm that late 90s, the 99, 8 onwards, and then especially in our Indian after 2000 we start coining this one based on the Paradigm cyclone 99. Super cyclonic storm with a T intensity number of 0.5, a sustained wind of 120 knots, is almost close to 240 km per hour speed. So under this condition, probably the center of the storm will be a low pressure system, and an outer periphery with the nearest point wherein the normal pressure can be without any ambiguity. So that delta P is the difference between center core of the storm and then the neighboring pressure. So that is the delta P has been given over here. Governing this one and then the maximum wind speed, there is a relationship which has coined by Fletcher. Fletcher's formula we used to be famously known. For Indian condition, it has been modified as 14.2 square root of del P. That is, del P is the pressure defect from the center to the outer periphery. So there was actually even the first day, that eye walls, etc. As I said, 2 eye walls, whether it is possible. I told even 3 eye walls are possible. And the right hand side picture shows 3 eye wall. Though you not been able to try to see based on the computer, very actually based on the analysis, as authentic meteorologists we used to say. The second one, the 2 eye wall, you can very well see A is the first eye wall and then B is the eye wall. In between, a small thin line is separating. Otherwise, both are rugged clouds, eye wall clouds, very strong downpour, very heavy winds, etc. The similar way here also, one, second, third. That is the way in which we are coining it. It's a 3 eye wall cyclone. This one has hit Machilipatnam in Andhra Pradesh, and then this one has gone to Bangladesh coast. In the operation setup, the HRPD ground station, receiving station, and then processing station was installed in Chennai in southern peninsular India. It was in vogue right from 1996. In 1998, there were as many as 4 storms. All the 4 storms have been analyzed. For that, the clue I took it from Simpson, who did reconnaissance flight in US on a hurricane storm, and she was coming to conclusion that no, the altostratus cloud, middle cloud, that is medium cloud, we used to say, altostratus cloud outflow in the mid-level, mid-troposphere. So that was giving us a what you call precursor that the storm will be going in that direction. Prior to that, all our data forecast and then model application, we used to say that the cycloning will be governed by a steering flow, which is at a higher height, maybe 200 hectopascal level, which is corresponding to 12.9 kilometer or so. So that wind alone will be steer the cyclone either towards western side, northwestern side, or northern side, or recurving towards the eastern side in Indian parlance. So this was the very first work somewhere in 1954, reconnaissance. They are venturing the live, and then with that they flown over the cyclone Hurricane Fury. Their language is Hurricane Fury, and then put a drop sound and then measure the temperature. This that all ultimately come to the conclusion that a warm ultrastratus outflow will act as a vertical precursor for that. So because the house data was available, we looked into, and then we ultimately found out on different layers on standard millibaric level, mean temperature, what could be the signature, whether any warm signature is available. That the cyclone has a what you call fascination to move until that. That is what inquisitive in nature we just pulled on. I just to show 1 or 2, and then probably the reference has been given. How in the day-to-day application the satellite is giving a better prediction. That is my idea is. So first one is the Arabian Sea storm route. You can very well just look to what are the tracks, etc. Then it will be useful for you. One track over Arabian Sea, another one near Andhra Pradesh and Visakhapatnam. Third one is over West Bengal, and then fourth one is over the Myanmar coast. Is the Arabian Sea storm, probably even far ahead for we call before landfall was long after 3 or 4 days, and then from the depression stage itself, the warm core was going on. There is a cold packet, is a cold packet in between the warm packet. So as if a warm trunk is protruding. Here it is very nicely seen. K stands for cold. So the temperature is cold value. The temperature is cold value. Here is the warm value in comparison to the cold. The cyclone is somewhere here. It has a fascination to move over here. So that is what that study was saying. That is the layer of 700 and 400 hectopascal mean layer temperature that gives us a precursor, and then that is nothing but the level of what we call medium cloud, which Simpson was saying through reconnaissance flight. And it was even showing some time, it was moving towards the fascination because cold, which I saw about this on the Nilofer storm in previous month. So it was only known observation is having a what we call tendency towards the northwest movement, and then later on it has just changed. Ultimately, it crosses somewhere here. So that also has been well captured in this particular storm. You can very well see that the storm ultimately has gone, and then we are away from the coast about some 300, 400 kilometers. 24 hours to 30 hours time for the storm travel, and that is best till time available so that in the following people they can be evacuated. And then this was done in the offline mode. Ultimately, probably we have to use the operation setup. That was the idea. So the next storm, which was crossing the Vizag coast in Andhra Pradesh, you can very well see the cold packet here, warm is here. So the cyclone is here. It is going and the tendency towards the warm packet. So this is the warm tongue. So a tongue is protruding out of the cold way, and then that is why it is called as the warm tongue concepts. The next cyclonic storm, which is going and hitting the Bangladesh coast or Myanmar coast, Myanmar coast. So this also is showing I'm just rushing up because before the internet goes bad, and I would like to give about microphysics. So these are all the legacy part. And the last but not the least, in 1996, there was another cyclone which was rather no numerical model was able to say that this particular cyclone was having south travel. Normally, cyclone has the tendency either westward or northwestward or northward or recurving towards the northeastward. So southward travel was not there. In addition, it was having a looping pattern. It started with this one and then go back to the eastward and then had a loop and then come down, something like that. Like this. So this looping also was not targeted. Unfortunately, our data is available only third, and then we were having at the time our receiving station problem, and then we rectified it. From third onwards, we tracked on. Storm crossed only on 7th. Still, we were comfortable. We were able to capture the southward movement, which could not be captured in any of the models, numerical models at the time. So here you can very well see that storm was having normally based on the third nature, it's activity there, and then the any time onwards, the times are given over here from 2055 UTC onwards. It was giving an indication that complete southward movement, which none of the numerical model could give. So that is the advantage of using a TOVS data on which not available from the conventional radio or something like that over the oceanic area. So ultimately, the southward movement and then was located within some 25 kilometers, 30 kilometers, which has been fixed the kilometer way. So this is how it's useful as it is. So this is a legacy, and then thereafter the 8 house came in, and then that particular system was available in Delhi, and then we started looking at, and then this storm prediction on 2002 there was a depression, 2003 there was a cyclonic storm. So both the movements, this is the house based, and then the finally forecast position base. You can very well see that the difference is hardly about some 35 to 75 kilometers at any point of time, the center fixing. So this is the depression case, the temperature anomaly between the center of the depression and then the out periphery. So the anomaly. So this is for the cyclonic storm. You can see that cyclonic storm, we are always saying as a thermodynamic heat engine, as somebody was pointing out in the lecture. So it's a warm core system. So the temperature anomaly of the cyclonic storm is somewhere 13 degree higher than the periphery. So it is about 30 degrees. So that has been captured. Though through earlier reconnaissance, etc., we were documenting it. Through 8 hours, we re-established the facts. The depression was having what you call a large convective instability. This is the vertical equivalent potential temperature, vertical profile. Theta E, we used to say equivalent potential temperature, which is nothing but the static and moist convective energy. So any lapse is called as the convective instability. So deep lapse is there. So for a cyclone to develop, normally we require weak vertical wind shear and then weak lapse. Then alone it will be in a position to have. Moreover, it should have more maximum thermal potential from the oceanic area. So this depression was very close to the coast, and then it has very minimum sea travel. In addition, it was having a deep lapse rate, and then there we ended only as a depression. Whereas in this case, this is a cyclonic storm. So the cyclonic storm started from the depression family. The lapse was very, very small in comparison to this one. This is a steep lapse rate. This is a small lapse rate. So this is needed for what you call gaining the energy for the cyclone for the low pressure family to become as a cyclonic storm. So that has exactly happened. The depression matured into a cyclonic storm. So that has been well documented through the 8 hours nature. So coming to the Bijli, I was talking about the scatterometer wind in the last module, and then this particular storm was continuously having only T2.5 as the what you call intensity number, which is almost like a child cyclone, very infant stage cyclone. So this cyclone center fixing was a problem, but at least in one case we are able to see that one can fix the center. And for this, we are using the quick scatterometer wind, which was very much used up to 2008. But unfortunately, in this particular case, the quick scat was giving a different position always. So longitude-wise, was telling latitude-wise was differing by right from 1 degree up to 5 degree difference. So this sort of thing probably initial stage will be noted. Then probably we want to believe either the satellite image given by the INSAT or the scatterometer wind given by this quick scat. After seeing this sort of vertical difference initially, probably we just wondered, and then ultimately we came to a conclusion that QuickScat had a problem because it was already having 10 years lifespan. Probably there could have been some deterioration. We corresponded with the launcher group in Nova NASA, and then so we also sounded them. Ultimately, they agreed in the month of June. that probably QuickSat had some bearing problem, and then probably we have to look into, we have to carefully use. So already we dispensed with in the April storm itself. It was out even by 5 degrees. 5 degree means 500 kilometer. 500 kilometers and fixing are out probably in the operational forecast. Now we cannot do any justice on it. So that is what I have been showing in 2-3 slides. But anyway, it worked up to 2008. Very nice. So cyclone has gone somewhere here, and then center is somewhere here. So you can very well see that the cyclone position is about 18 degree north, and where putting the cursor is somewhere around 13 degree north. So 5 degree, 5 degrees, 500 kilometers. So it is why the data quality. So it is all because of the technical issue, because the wear and tear also matters. And then later on, as started, and then oceansat from India started. So normally, the life period matters. Period of the cyclone slide. So the next one is the Hudud cyclone. Probably this is from the our METAF station receiving instrumentation installed in Chennai itself. So this particular storm in the normal black and white picture, and then with advanced sensor of this different polar orbiting satellites. So both are very fantastically picking the same occasion and fantastically giving the position. So that is why the satellite usage and then utility, but really helps us in the operational stuff. So the images used, which already discussed, and then only for your information, what is mid-AR, what is water vapor, and then that alone, for that reason I kept this slide. Otherwise, there is nothing great in it. Now, identifying the signature only on black and white, it requires some experience. Whereas the color combination, probably if somebody is wearing a dark red shirt or something like that, we have, it's an alarming. What we call the human mentality is tuned for some colors. So that is why the satellite technology also, the products have been coined in red color, blue color, and green color, and then different combinations in the product generation. Third module, we just introduced the concept, and different service providers are using different channels, and then the identifying. In a nutshell, probably the higher and then lower, etc. What is used, what is used, that is idea. So seeing is believing. The pictures that will throw a good light, and then how probably the different signatures can be inferred. So based on the previous slide, the microphysics involves. So the number one, which corresponds to large warm ice. So we saw deep red in visible reflectance, 0.6 or 0.8, depending on the service provider. So this reflectance is used here. So this deep red is nothing but a large warm ice core. And the second one is not that deep in red, but relatively a lesser red. So that is large cold ice. Then a small cold ice is a red family alone with orange. Okay. So normally we know, red starts from orange and then goes on increasing with the color shades. So you have large warm ice, large cold ice, and then small ice. Okay. Then water and then ice contamination. So that is having a green color combination, and then this also a green shade, a green, a grayish green, something like that. Bluish green. Any form you can call, because there are 255 colors. What to call that we have to depend. Only our eye will be having sensitization towards this one. That is the idea of our what you call interpreting the picture. Only a mere small water droplets or something like that, that comes in the form of very, very gray shades like that. So now identifying, so that particular microphysics, now I'm legacy, and then that way only I organize this particular layer. A legacy picture of black and white, a jet core, a jet stream for that. It is the large core of wind concentrated on quasi-is having length of thousands of kilometers, and then a breadth of tens of kilometers, and a depth of a few kilometers, having a minimum wind speed of 60 knots, and then having a vertical wind shear of 5 to 10 per kilometer, 5 to 10 meters per second per kilometer, whereas horizontal shear is 5 pace hundreds of kilometers. Vertical wind shear is much high. That is the idea. Having 1 or 2 velocity and the cone, it's a single sentence for jet core definition as per the WMO. So that's been highlighted for understanding what I discussed. And jet core in the earlier legacy picture, we are seeing that a cloud of normally that core will be at the upper troposphere, it will descend even up to 9 kilometers or so. Especially the subtropical westerly jet stream, which is a perennial jet stream, which is meandering throughout the globe over the Indian, will come even up to 18 degree, 19 degree latitude. Otherwise, it will be away or above the 35 degree north foothills of Himalaya. So normally this set of cloud signature as a cirrus cloud will be in a sea. Cirrus cloud, if it's sheet, the jet having a high vertical wind shear that is 5 to 10 meters per second per kilometer, that chops off the cirrus cloud as if we have fine saw is making a what you call cut along this one. So that signature is given here. You may not be in a position to appreciate because this is a legacy picture, and then in the current day picture you will be in a position to relatively understand them. So the jet core, jet stream, probably you can identify from the satellite picture also, and then through the surface drawn charts and other things, synoptic analysis also, we will be in a position to have. We are concentrating only on the satellite-based instrumentation. So the current one is 2016 picture. You can well see that you can well see there are some chopping off. That is nothing but the transverse wave. So if this is the horizontal, the transverse wave type of phenomena is chopping out, and then due to the vertical wind shear. And seeing is believing, the same one, the micro 6 slide, and in addition, the cloud motion vector we derived based on some other concept that we are going to see in a few more slides also. So the topmost what you call the blue color is between 150 hectoscale. That is somewhere the order of what you call 11.5 kilometers up to 14 kilometer height. So over that, what is the value of the wind barb, and the next one is up to maybe about 9 kilometers. So the wind barb, etc., whatever was available in the satellite, that was suggesting that a jet core was prevailing that way. So here one more jet stream in 2018 February. As I told you, this is the subtropical westerly jet stream, which is perennial, and then it comes over the Indian area. In the yellow color, and then here you are unable to clearly see the Indian coastline. Okay, so it's this is when it goes on. The RAM will be coming on this way. It is concentrating on a quasi-horizontal axis. It is not like a rock steady flow of horizontal wind. So it will be having a pattern like that. So on this particular day, it was coming from up to this latitude, and then it was going like that. And then in the extra traffic, probably it might have gone in the globe elsewhere. So here you are able to see the winds derived from satellite, and then probably that is also suggesting jet core can be identified through cloud motion vector, atmospheric motion vector, and then water vapor wind technique, etc. In addition, the signature on seeing. So with this idea, probably I just wondered what exactly was the signature when I was asked when I was working at Delhi. Somebody asked me whether it is a jet stream or something like that. Whatever I have highlighted here. Are you able to see this one small picture of this one? This is again a cloud signature only, but only thing you are unable to see the transverse wave of thing very clearly over this. This is for the visible picture. This is the short wave IR picture, and the wavelengths have been highlighted over here. So I am just showing some 6 channel pictures. That is why I kept the 6 window channel characteristics as a slide. The visible and the short wave IR we are seeing. Now we are seeing the mid IR and 3.9, and then somewhere around 6.8. So wavelength, you will see from the pictures it is. So here, whatever you could not see clearly there in the visible and short wave IR, you are able to see the cloud signature as such. And here you are having some what you call transverse band. Okay, so you are able to see that there is discontinuity in the band. Here it is not that significantly visible. So the next one is our window channel, infrared channel 1 and infrared channel 2, 10.5 and then 11.5, that is the center, and then probably whatever the wavelength is used, they have been highlighted over here. So the transverse band you are able to see very, and then here also we are able to see very nicely. So with this vertical in mind, and what we saw jet stream, whether it can be considered as a jet stream, that was a stream. So the question has not been answered. I am coming to the answer now. So the same one with the microphysics we apply to, and then the 3IR1, through that, we can infer the temperature. The temperature scale has been given over here. So it goes to the blue values, blue shades, and then blue shades corresponds to minus 38 degrees Celsius according to this one. Once I zoomed and then enlarged, I was able to get. In addition, there are some green shades and then available, probably that corresponds to somewhere positive temperature, which may be at a height of some 4 kilometers. So now it was giving an idea whether it was a high cloud or it was a medium cloud. So that is the confusion, especially in the RGB color pattern, and then probably if the signatures are coming from multispectral channels, because we are combining three channels together. So that is why the interpretation was rather tricky. That's what I started with. So it gives an idea somewhere cirrus cloud and then cirrostratus cloud of higher altitude, that is also available, and then in addition medium cloud is also as a signature is possible. So we can very well think that because of what you call chopping off or something like that, some cloud have gone down and some clouds might have gone up. That's quite possible. That's what I already hinted like this. So now the shearing is very much same. So the shear causes probably the movement of clouds up and down, and then in between whatever chopped off as a signature, we are able to very nicely decipher right from 3.9 mid-IR band up to 12 TIR2 bands. Okay. So now whether it was associated with the jet stream or only shear induced cloud, that was a question to be or remaining to be answered. So we already identified this is the vertical shear pattern cloud, and vertical wind shear was causing a havoc for this cloud. That is only the problem. There is no cloud storage. If the wind speed over that particular area exceeds 60 knots, then we can say that this is jet stream. But unfortunately, the jet stream during this particular period, it was that deep, what you call down south to Indian Peninsula. For that, we have to take care of what you call the GPS on data, etc. So in the last slide, being an aviation man, at the time I was working for Central Aviation Med Division at Delhi in MD, and probably we were introducing the area forecast system maps, which is working at Bracknell, London, and Ocean for the whole countries of ICAO, and then we are supposed to use the product. So the clear air turbulence, by name, it is clear. So the turbulence which is not in association with the cloud is called as clear air turbulence. The turbulence which is not associated with the convective cloud or not in the vicinity of convective cloud. By convective cloud, we mean cumulonimbus, towering cumulonimbus, and cumulus. Okay, so that sort of thing. What you call cumulus, towering cumulus, and cumulonimbus. And any this sort of convective family will always be having the turbulence. So there is in the clear air or in any cloud other than this convective cloud, turbulence there, that's called as clear air turbulence. So the clear air turbulence signature, it has been well documented in aviation literature right from 1960. There are different numerical model indices available, Wilrad and Knapp by Enlich Mancusa, and right from Richardson 1930, 1940, origin, etc. In fluid dynamics, there are some what you call empirical formula derived for it to identify. So based on this numerical model, we are in a position to get what you call the WAPS type of forecast, which is available to the aviators. And while they are normally flying at the altitude of 9 kilometer to 15 kilometer, they will be experiencing this set of clear air turbulence, because normally the clouds will seldom exceed, they seldom penetrate to that height. Okay. So here the WAPS was showing for 300 turbulence, which is 9.8 to 9.9 kilometer usually for Indian range for precision, and 200 Pascal, which corresponds to some 12.8 kilometer, and this has a corresponding temperature of 21 to 28 usually, and this corresponds to a temperature of 50 to 58, whereas in our case it was somewhere the order of minus 38. So both were not coming, and then this is having a very limited possibility of clear turbulence over this area. This has relatively, maybe this is having about 5% probability. This may be some 8% probability as per the concept of vertical harmonized WAPS product. The next one, in between layer, that 300 hectopascal and 200 hectopascal, we saw in between another layer called 250 hectopascal, which corresponds to somewhere about 11 kilometer height. So 10.8 to 11 kilometer height, that is the order. Here we are having a good possibility of clear air turbulence, which has been predicted by the numerical model, which was produced by the WAPS centers to buckets of world for the aviation flight flying, especially international aviation purpose. So this was told as a clear air turbulence. A turbulence which is not associated to it or which is not in the vicinity of convective cloud. That is the definition. So this also suggested that probably whatever signature we saw over the same area, so the waves also was supporting. So it is nothing but a shear induced turbulence which was the signature. And nowhere in the neighborhood of that particular area, whatever radio sound is having, we got a wind speed exceeding 60 knots. The maximum was 40 knots. So that's why I conclude that that particular signature was shear-induced turbulence cloud, not as a jet stream clouds. So based on the experience, we will be in a position to decipher this sort of thing. Now coming to the cloud motion vector, which I was saying earlier. So we started with humble beginning of what we call pattern recognition technique, and then based on the human eye and the trace the subjectivity of the experts who is analyzing it, and on seeing a visible picture how a cloud patch is there, and after next 30 minutes or so on seeing the same area whether the cloud picture has moved or not, with that in which direction it has moved and with what velocity or with what speed it has moved. So that way, because I already told about the direction, that's when I will say only the speed. So the velocity can be estimated as such, and then clear motion vector and the pattern recognition technique was the earlier one, and manual was then the computer age started. We started analyzing it, and then there is something called the cross correlation technique. We identify the picture through visible images and then make some dots like that. Maybe we put a normal window as this one a reference window, and we keep on moving as a sliding window concept of some 15 pixel. Each pixel at the time it was 2.7 kilometer resolution. So we slide across so many 15 by 15, and then there will be innumerable, because the outer one I have taken for example 37 pixel by 37 pixel. So that itself is a huge area. 37 multiplied by 2.5 degree, and 2.5 degree means 250 kilometer. You can just imagine what is the numerous value of what you call length and breadth. We will be doing it. So this particular pattern we are just matching with the neighborhood with one pixel. That is called a sliding window concept. So we work out the cross correlation, and then with that, where exactly the best match is there. So that has been picked up. That is considered as the atmospheric motion vector, cloud motion vector. The earlier views. Now, thanks to the recent channels, 67 micrometer wavelength band introduced in the satellite imagery channels and sound, etc. Probably we are having much more affordable. So this is sensitive to the water vapor. The water vapor probably through that the signature can be identified, and in the form temperature we are in a better option to have. It is called as water vapor wind vector technique, WV technique. So currently we are using that particular technique. So with this introduction and what a layer mean average wind, and then that is what in the period show you. So this very pale blue color somewhere it is shown here. So then yellow color is somewhere shown here. These corresponds to different layers. Green color much more is available. So even over the circulation pattern, the estimation also suggesting circulation pattern. That is the attraction of what you call wind estimation to satellite or vapor technique. Oh, the earlier days, we talked about the scatter wind of vertical quick scat and other thing. Scatterometers normally on board satellites, the access centers like radars are used, and then they send a pulsation, return pulsation. With that, they transfer. As I told you, the carrier of centimeter wavelength that was captured a signal by quick scat, and the current day probably the scat and then EMSat etc. is coming in. This slide I have kept there also. This particular bullet, not slide. So you will see ocean, water, etc. Probably this set of what we call ablation that we are calling as a capillary wave. The quick scat image, you can see that even up to 2008 we were comfortably using it. That we already discussed, and then probably I will not spend much time on it. And it's all path dependent. That is the only problem as such. And then the current aspect on board meta satellite. So this I took the ever latest 2019 June prior to onset of monsoon. So you can very well see that the westerlies have been established. Only thing it has to come and hit over the coast, and then normally it has what we call estimation only over the oceanic area, because it raises capillary wave type of information. Then alone the radar will be getting the signal. Okay, so that's why near to the coast you will not get it. Probably only over the deep sea water you will be getting it. That is the reason probably why the cutoff is there. So it is giving what you call a very good signature that probably the very next day something could be possible, and then exactly on 8th June or something like that, the monsoon onset has been declared, the current year. So there are phenomena through microspectral imagery we will patient estimate, and then one estimation is maybe on western distance, which is coming from the Mediterranean Sea from the west and then hitting over the India, especially during the winter months. It is very vulnerable, and it causes a lot amount of what you call chill temperature, cold temperature over the Delhi and the northern pockets of India, and it gives hailstones, snowstorms, etc. So in a normal black and white picture, and then visible color imagery picture, how it is different, and then multispectral way, how we get the nature of small ice crystals and then large droplets contaminated with ice crystals, mixed facings. So you can compare and contrast the day microphysics and the night microphysics, which we discussed in the previous lesson. And the red color is the difference of temperature between the IR2 channel and IR1 channel, the red color. And the green color is the brightness temperature between the TIR1, that is IR1 channel, and the mid-IR, which is about 3.9 micron, which we discuss about. And the blue color is only about the IR channel 1, which normally we saw even for the jet stream and the other what all wind shear induced or chopped off cirrus pattern cloud. So here you can see that the compare and contrast between the daytime and nighttime. So what is applicable in day, probably some amount of difference is there. That is why in the night images probably will not getting confused with the current concept of color coding, etc. Even operational duty person who are working during night time, they will be in a position to get the signature of what is the weather phenomena. So that is the alarming way in which it has been put over here. A squall line thunderstorm. By squall line we mean thunderstorm cells which are normally having the diameter of about 4 kilometers in depth and about 6 kilometers and above, even up to 18-20 kilometers or something like that, and then depth etc. maybe about 2 to 4 kilometers. It's a single cell of thunderstorm. So they align. Sometimes they spread over 250 kilometers, 300 kilometer radius circle. So these thunderstorm cells, if they align like a straight line or curved line etc. with no gap in between or continuously, and the length and the breadth ratio is a minimum of 10:1. That what I mean to say that 100-kilometer length of thunderstorm cells singularly they are available. Probably the breadth will be a minimum of 10 kilometers if it's available. So they are called as squall lines, squall line thunderstorm. A minimum 100-kilometer length should be there. That is the first criteria, and the ratio of length is to breadth is to be at least 10:1. So then alone a line type of signature you will be in a position. Say otherwise, you will be seeing a dense type of pattern. So that probably you will not say. That we will be saying as a mesoscale cluster, mesoscale system, etc. That's a different concept. So now squall line thunderstorm, which travels right from Bhubaneswar or even Calcutta up to Andhra Pradesh or northern pocket of Tamil Nadu, it has come like that. So these probably with the IR channel we are having a temperature of order of -40, -50. That corresponds to 12 to 13 kilometer height. The cumulonimbus cell has gone from surface up to that height, and then this is the signature. So especially for the aviation, this is the vulnerable signature, and then overflying is a problem. And the moment we want the pilots, so they will be either circumventing or they will be having much more caution, because at any cost they have to cross. Otherwise, in the circuitous way, it will cause lot amount of fuel and then loss of what you call money on spending the fuel and then time, etc. That will be a problem. So this is giving us a warning either that the departure will be delayed or they will be avoiding, or where there is what you call a minimum area at which they pass, or they can fly over and then cross. Fly over also sometimes the turbines will be acting on. So that sort of thing. That is why as an aviator probably this signature for that we used to give sufficient warning in advance. So normally we know that monsoon clouds, so there will be a trough on the monsoon, and then if the monsoon goes to the foothills of Himalaya, that is almost considered as a break monsoon. It's the signature very close to the foothills of Himalaya. The trough has gone in, and probably so over that area is having it. So it's not actually a break monsoon, but over the trough area, the cloud signature are seen. You can see in the black and white. You can see in the microphysics. So monsoon trough also we can identify through this imagery. So the northeast monsoon, which is a additional monsoon for India, that is returning south monsoon is northeast monsoon. The original parlance, the winds are coming from northeast, from the northeast side, the south direction, and it is coming from the Eurasian cold land. So the arrival of northeast monsoon winds and then cloud pattern also captured well by the imagery of satellites. So from the signature of whatever we saw in the dry microphysics, I think I am coming to a close in another 7 slides only. The day and night microphysics, different service providers of the satellite, they have different thing, and then probably I am just showing some 2-3 service providers point of view. Meteosat second generation group, so they are using what is the red color, what is the green color, and then what is the blue color. And thanks to Professor Daniel Rosenfeld, I am having this particular slide. So only one image that speaks about the utility. You can very well see that deep red color are large ice crystals, and has been shown in single solution chair. I will show you compare and contrast a black and white picture. The same one you can just identify. Here itself we have mentioned that it's a CB cloud. Probably the temperature is at the order of -2. Status cloud, fog, and then here in the color how it is changing, you can very well see the same picture. So whatever we saw, the same thing I have mentioned here, and then the red colors are corresponding to CB cumulonimbus cloud and altostatus cloud and stratus cloud, and then you can compare and contrast between the stratus cloud, which is also a low cloud. Fog is also a low cloud, or cloud very close to the surface. Fog can be conceived in that way. So what is the difference between these two? Whereas in the black and white, you are unable to distinguish that clearly. I am going back only for your information, especially for the low cloud identification. So this signature may be almost same dull gray shades, okay? But here it is nicely captured between two color contrast. So that is the advantage of current day technology. And then the snow signature, it is almost like your what you call ice crystal signature, pink type of red, okay? This also we saw in some earlier picture. So the different combination on physics, the earlier we saw day physics, and then this is the night microphysics. So the same picture, CB, only thing the channel difference has been changed, and then this costs what you call, this is the ever latest one. Probably ABA is also using in the US. It's also contemplating like that. But I am quite comfortable with the earlier. Now also they are saying that here itself, you can distinguish between a low cloud of stratus and then a low cloud of stratus. There is a color shade. There is no difference. But still, I have a feeling the previous one was much more appealing. But the current day also somebody is preferring. There is ongoing research going on, and then with that, every world community they will come and see like this. So this is a summary of Rosenfeld's day and microphysics, which we saw earlier in different developed columns. Now coming to the insert. From the satellite, we can estimate the quantity of precipitation, which may occur. We started with the humble beginning of what all Arkin's technique, which our previous DG of IMD, Dr. Kelkar, was using, and then over point location, etc., identifying some cloud patterns of temperature 230, 235, 240. That was the order. Ultimately, it was settled at 235. So that was the earlier technique. Nowadays, the satellite derived temperature is available. Spatial scale, we are in a position to estimate the quantity per plane estimation over vast area. So that has been depicted here. It uses the temperature channel data, and it uses what could be the quantity of precipitation. The legend is with the given so it is available. All satellites are available online. So okay, viewers, with this probably the application satellite picture on image and sound data utilization day-to-day weather that is completed. With this, probably I acknowledge the source provider, the in my own contribution, what is available, and then some amount of what you call it is available. This let me look on, and if